Okay, so what we have here is another input-output type problem where we have three commodities that are interdependent on each other, and we want to know how many units need to be fed into this system so that we end up with 8,000 units of electricity, 12,000 units of water, and 3,000 units of petroleum. So right away, I'm going to label this as my demand. So that means this is going to be 8,000, 12,000, and 3,000. Okay, and that is electricity, water, and petroleum. So that means when I set up my consumption matrix, technology matrix, the matrix that tells us how much gets used in process, I'm going to use those same ordering. So we have EWP and EWP. Remember the from and the to. So what we're looking at here is, so to produce a unit of electricity, it takes 0.6 units of water and 0.3 units of petroleum. So that means this is a 0. To produce a unit of water, we need 0.6 electricity, no water, and 0.2 petroleum. And likewise for petroleum, we require 0.3 units of electricity, 0.1 units of water, and no petroleum itself. So there's our A. So remember that we need to compute X, which is I minus A inverse times D. And actually, I has to have the same dimension of A. So that means I is a 3x3 matrix in this case, okay? If we had 5 variables, we would need a 5-dimensional identity matrix. And boy, that would be great fun to do too, wouldn't it? So what we're going to do is we're going to input A and D into the graphing calculator and let the calculator do the talking here. So coming over here, we have, I'm going to go to the matrix menu, I'm going to edit. I'm only going to use matrices A and D because, again, same letters makes it a little bit easier to jibe with the formula. So I'm going to edit A into a 3x3. Whoops, I don't know what happened there. It made it 33. 3x3. And remember, this goes by row, so that's why I always encourage writing it down first before trying to do the problem. All right, so there's our matrix. Everything looks good. Okay, so I'm going to go back into the matrix menu. I'm going to edit D into a, whoops. I'm going to edit D into a 3x1. And it's not going down there, so I just have to touch that. Okay, so 8,000, 12,000, 3,000. All right. So then, now that's basically it. The calculator can handle the rest. So going back out to the main screen here, so I'm going to, again, I want to do this big complicated inverse. I got to use a left parenthesis. And I go to the matrix menu. Identity is under math, and it's number 5. So identity 3 minus matrix A, and somehow it looks like I got an extra minus in there. Okay, that looks good now. Okay, inverse. So all of that is the I minus A inverse, and then I'm going to multiply that by D. And there's our answer. So that's how much needs to be fed into the system in order to create the desired external output. Notice what this looks like is, so I'm looking at the electricity. Well, they're all kind of really high. We need to input over 35,000 units of electricity in order to end up with 12,000 units of electricity extra. So that's kind of telling right there too. That means we use a lot of electricity in production. So there's a lot of things we could actually surmise from this, but for now, all that is how much is required of each one, and we have reached our goal. Thanks for watching. Hope you found this helpful.